topic class is going to be called Solving Systems. You should take some notes. Solving Systems of Equations. Using elimination. So this is called the elimination method. So say that what? So say I have a set of equations. I have one that is 5x minus 6y minus 6y equals negative 32. And then I have another equation that looks like 3x plus 6y equals 48. Okay? And they say solve the system. Okay? And usually they'll have like brackets on it like this. And so you could solve this by graphing them and seeing where they cross. Or you could do it by substitution, but substitution would be really hard because you'd have to solve for y, and then you'd have to take y or solve for x and plug it back into one of the other equations. But an easier, yes sir?
How do you get 48?
This is just the problem. Now, this is equation 1 and this is equation 2. Okay? So if you have two equations like this, and you want to solve them, what you do is you add the two equations together, okay? And this is a nice thing to do because if I add, Michael, if I add these two equations together, what's 5x plus 3x? 8x. And what's minus 6y plus 6y? 0y. So this goes away. See that? And then I add negative 32 plus 48. Anyone tell me what that is? Not 26, close. 16. And then all I have to do is divide both sides by 8. And I get x equals 2. Okay? Now I do still need to find y. Okay? So I take my x and I plug it back into either of the two original equations. Okay? And it doesn't matter which one you use. Okay? So let's plug x back in here. So if I were to plug x into this equation, I get 5 times 2 minus 6 times y, right? 6y equals negative 32. And then I have to solve that for y. So I get 10 minus 6y equals negative 32. What do I do to both sides? Minus 10. So I get, that goes away. I get minus 6y equals negative 42. That's negative 32 minus 10. And then I divide by negative 6. Divide by negative 6, and what do I get?
Negative 7.
Positive 7. Negative divided by negative 7. And just to make sure, what you should really do is take those two answers for x and y and plug them into the other equation to see if it makes it true. So in this case, I'm just going to do that. If I were to plug x in here and y in here, right, what I end up with is 3 times 2 plus 6 times 7. And you want to know, is that equal to 48? And 3 times 2 is 6. And 6 times 7 is 42. Does that equal 48? Does that equal to 48?
Yes.
Yes. So my answers that I got for x and y check when I plug them into my second equation. So that's called solving by elimination, meaning you're getting rid of one of the variables by either adding or subtracting. Okay? So maybe you try. Got it? So we're going to do one of these. You try. You try. Okay? So see who can come up with the right answer. I have 6x minus 3y equals 3. And then I have 6x minus 6x plus 5y equals 3. And you solve the system. See what you can come up with. Ready, go. I'm going to bring this right back. I just got to find my recorder and pause it. Pause it. Okay, so anyway, what Charlie probably did here is he added these two equations together, and this goes away, and I get 2y equals 6. This is a pretty easy one. Divide by 2, right? And I get y equals 3. So now you have to go back and you have to find out what x is. Not what y is, but what x is. So I'm going to plug in y as 3 there. So you go 6x what? Minus 3 times 3, right? Because it's 3 times 3 equals 3. So I get 6x minus 9 equals 3. I add 9 to both sides, plus 9, and I get 6x equals 12. And then I divide by 6, and I get x equals 2. So that's, Charlie was right, he even said them in the right order. And again, what you should probably do is plug both of those values into the second equation. If this is equation 1, which you already kind of used, and this is equation 2, I take those two numbers and plug them in here to check. So the check is going to look like negative 6 times 2 plus 5 times 3. And you want to see, does that equal up to 3? Okay? And so I get negative 12 plus 15 equals 3. So yes, 3 does equal 3, and it checks.
So Mr. Leader, don't we have to write that in an ordered pair?
As an ordered pair, you should write that as 2, comma 3. Right? Always x before y, just like in the alphabet, x and y. Okay?
Okay.
Now, unfortunately for you, it gets harder. Okay? So, and then it gets harder than that a little bit. So let's just look at this one. 2x plus 5y equals negative 22. And then I have another one, 10x plus 3y equals positive 22. Does anyone have any idea what to do with these? Okay? Because if I add them together, is anything going to disappear? Or x or y is going to disappear?
No.
No, maybe the 22s will disappear, but that doesn't really help you. Okay? So what I do in this case is I look for a number that I can multiply one of these equations by to turn it into this number down here. What could I multiply 2 by to make it into 10x? 5. Except instead of multiplying by positive 5, I'm going to multiply by negative 5. And the reason for that is because when I add, I want the negative 10 to go away. Okay? Or the 10s to go away. The 10x's. So when I multiply this, I have to multiply everything through. So I get negative 10x, and negative 5 times positive 5 makes negative 25y equals, and not only do I have to multiply this, and what people always forget to do, they have to multiply this by negative 5 as well. So negative 5 times negative 22 makes positive 110. And then in the bottom, you bring this one straight across so that you can line things up. 10x plus 3y equals 22. And now you take those two transformed equations and I add them together. What happens to my x's? Boom. Okay? Negative 25 plus 3. Anyone know what that is? Negative 22y. And 110 plus that plus 22 makes 132. 132, not 136. 132. And then I divide both sides by negative 22. By negative 22. And I get y equals negative 6. And again, you got to find x now. So I'm going to take that, I'm going to turn it purple, and I bring it, no, I'm going to turn it, what color is it? Let's turn it red. Let's turn it red. Okay. And I'm going to take that, and I'm plugging in here for the easier equation, I think, is this one, because I don't know which one's easier. Doesn't matter. Okay. So now I get that, when I plug that in, I get 2x. So plugging that in, now I get 2x plus 5 times negative 6 equals negative 22. And I get 2x minus 30 equals negative 22. And then you add 30 to both sides, plus 30 plus 30. And I get 2x goes away equals 8. So divide by 2, divide by 2, x equals 4. So as an ordered pair, I have 4, comma, negative 6. Okay? Write that down. Sorry. So the next example I'm going to give you, 2x plus 3y equals 7. Equals 7. And then I have 3x minus 2y equals 4. Okay? Now here's the problem. There's nothing I can multiply this by to make this turn into one of those. So what I have to do is figure out something that I can multiply them both by to make one of them disappear. Does anyone, like I have to multiply one equation by something and one equation by something else? Yep. So these will both go into 6, right?
Yeah.
Or these will both go into 6. Okay? So how do I turn this 2 into a 6, Alex?
You multiply by 3.
Multiply by 3. And how do I turn this into a 6?
Multiply by 2.
I would multiply by negative 2 because I want to turn it into a negative 6. So when I add. Okay? So now when I do that, and you can kind of see the reason he did that, is because now when I rewrite this one becomes 6x plus 9y equals 3 times 7, 21. And this one becomes negative 6x plus 4y equals negative 8. And now I can add. Okay? What happens here? Boom. Okay? 13y equals, what's 21 minus 8?
13.
13. So y equals?
1.
Y equals 1. So now I get y equals 1. That's a nice number. And then I take that and I plug that one into here for y. Okay? And I get, when I do that, I get out 2x plus 3 times 1 equals 7, or 2x plus 4 equals 7. Did I make a mistake? 2x.
1 is 3.
3 times 1, since when? I knew that. I'm just testing you to see if you're paying attention, Maria. Okay? Great. Good catch. You should get a valuable prize because you're paying attention. Should you get a valuable prize? Okay. Okay, so I get 2x, those go away, equals 4. Divide by 2, divide by 2, and I get x equals 2. Okay? And as an ordered pair again, I write this as 2, comma 1, x before y. And I'm just going to check this one to make sure it works. Check. 3 times 2 is 3 times 2 minus 2 times 1. Does that equal to 4? I plugged into this equation. 3 times 2 minus 2 times 1. You get 6 minus 2. Does that equal 4? Huh?
Yep.
Yeah, so it checks. All right? So,